Hey, y'all. Um, those of you that are watching this video, I talked for about 30 seconds without recording, so I'm starting over. If you were just given these two triangles with no markings, just ABC and DEF, and you wanted to prove that they were congruent using the side, side, side postulate, what would you have to know? Okay? Well, you would have to know that one pair of sides was congruent, another pair of sides was congruent, and another pair of sides were congruent. So, on different triangles. So we would have to show that AB on this triangle is congruent to DE on this one. Then BC on this one is congruent to EF on this one. Then what's the third one we'd have to show? AC on the first one is congruent to DF on the second one. And if all of those were true, then we could say triangle ABC is congruent to triangle DEF, because A is the same as D, B is the same as E, and C is the same as F. Okay? So the first postulate we learned last section was that if you can prove all three pairs of sides, that is sufficient to prove that the two triangles are congruent. Then once you know they're congruent, you know that everything's congruent. So after you did that, what additional information would you then know? That angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. So if you couldn't prove those before, if you can prove the triangles are congruent, then you would know by all three sides, if the triangles are congruent, then you know all three angles, and the reason would be CP-CTC. Corresponding parts, congruent triangles are congruent. Okay? So the first one you learned, first way to prove two triangles were congruent was the side, side, side postulate. Now remember, because it's a postulate, it's not something we can actually prove. It's just something that we accept as true. All right? Then we learned a second postulate. Who can remember it?
Yes.
Side, angle, side. Now what does that mean? Can somebody tell me that in your own words?
That the angle will be between the two sides.
Right. So you know that two pairs of congruent sides and the included angles are congruent. If those two things are true, then the triangles are congruent by side, angle, side. So let's go back to that same one we had, okay, where we had A, B, C, and D, E, F. So somebody give me three things that if we knew they were true, we could say these two triangles were congruent by side, angle, side.
Angle A is congruent to angle D.
Okay. If you knew that angle A was congruent to angle D, and then what?
Angle AB is congruent to angle D.
There is no such thing as an angle AB. Side what?
Side AB.
Side AB
Congruent to side DE.
is congruent to segment or side DE. Okay.
And then side AC is
Right.
congruent to side DF.
Y'all make sure to tell me if I start writing out of bounds. This is congruent to that. Okay? If that were true, then you could say triangle ABC is congruent to triangle DEF by side, angle, side. Okay? And then once you knew they were congruent, then you would know everything else. Once you knew the two triangles were congruent, if you needed it, you could say that now you know BC is congruent to EF. Or now angle B is congruent to angle E. Or angle C is congruent to angle F. Okay? So we've got side, 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 which is all three pairs of sides. We've got side, angle, side, which is two pairs of sides, and the angle in between. Okay? Now, go back here 1 second. It has to be that angle. If you just knew this, it wouldn't work. Remember, we said that's angle, side, side, and it's a bad word. Can't use it. Okay? So it has to be the angle that's between the two sides that you know. Okay? So now, what was the last one?
A and A.
Right. And you think about it, they have to always be symmetric. Okay? So the three postulates. You got side, 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 which is the same forward and backwards. They're palindromes. That's what it's called when something's the same forward and backwards. So you got side, 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 which is all three pairs of sides congruent. You've got side, angle, side, which is two pairs of sides congruent and included angles congruent. Then you've got angle, side, angle, which is like this, but the opposite. Two pairs of angles congruent and the included, it has to be included, sides are congruent. Okay? So right now, those are the three ways you have to prove, and those are three postulates. Okay? Well, today we're just going to learn one more, and it's actually a theorem. So what's different about a theorem than the postulates? What'd you say? We can prove it, so we're going to. Okay? So, here it is. So I'm going to state it, and then I'm going to prove it. Okay? So it says, 1 second. I want to use the same diagram as your book in case you want to go back and look at an example. Okay? So it's called the angle-angle-side theorem. Okay? Now, just like I don't care if you write postulate on the other ones, I don't care. If you just write angle-angle-side, that's fine. Okay? So what that means is two pairs of angles are congruent and a pair of non-included sides are congruent. Then triangles are congruent. Okay? Now we showed that that didn't work when there was two sides and an angle. When it was two sides and an angle, the only way it worked is if the angle was the included angle. It couldn't be a non-included angle. But this theorem shows when it's two angles and a side, it works even if the side's not included. Okay? So let's do a proof of that. All right, so I'm going to have two triangles. I'm going to call them A, N, G, and S, D, I. Okay? And we are going to be given that angle N is congruent to angle D and angle G is congruent to angle I, and that segment AN or side AN is congruent to side SD. And I want us to prove that even though that doesn't fit one of our three postulates, that we can still prove that triangle ANG is congruent to triangle SDI. Okay, so currently, before this theorem, what are our three ways to prove? And so I always say, go over on scrap paper. What are your three ways? Side, side, side. Angle, side, angle. Or side, angle, side. Right? Okay, so let's look at what we have. And just to help y'all understand, I'm going to write the three givens on three different numbers. Okay, so one, I'm going to say angle N is congruent to angle D, and I'm going to mark it. Now, why can I call that angle N and I don't have to call it angle GNA or ANG?
There's only one.
Because there's only one angle at angle N, so you can say that. If there had been another line here and there were two angles, you couldn't. You'd have to name the three letters. Okay, that was given, and I've marked it on there. Then we were told angle G is congruent to angle I. That was also given, so I'm going to mark it on here. G is congruent to I. And then we were told that segment AN is congruent to segment SD. That was also given, and that is AN is congruent to SD. Okay, so we know two angles and a side, right? But why can't we use angle, side, angle? What side would we have to know? What pair of sides would we have to know to be able to use angle, side, angle? To use angle, side, angle, we would need to know the side between the two angles. So we'd need to know that DI was congruent to GN. Is there any way you can prove that DI is congruent to GN? No. Okay. You only have a few ways of proving two segments are congruent, like by the midpoint, or if they're a shared segment, it's a reflexive. But we have no way. So first of all, we're not going to use side, side, side because we can't prove that DI is congruent to GN. So we can't even prove two sides. So we're definitely not going to use side, side, side. Well, if we can't prove another side, that knocks this one out too. So we've got to use angle, side, angle. What other piece of information would we have to know to be able to use angle, side, angle?
You gotta know the angle
Is congruent to what?
to angle A.
Right. If we knew that angle S was congruent to angle A, we would have angle, side, angle, and angle, side, angle. We'd have two angles and the included side. Two angles and the included side, right? Can we prove that angle S is congruent to angle A? Remember, we had a theorem that said if two angles of one triangle are congruent to two angles of the other triangle, then the third angles are congruent. So we know now that angle S is congruent to angle A. What's the reason? It's called the third angle theorem. But I usually forget that and I just write it out. And says if two angles of one triangle are congruent to two angles of another triangle, then their third angles are congruent. Well, now can we say what we're trying to prove by angle, side, angle?
Yeah.
Angle, side, angle. Now remember, you've got to use, so which angle, side, angle are we talking about? Talking about those, right? So to get the numbers, we have to say, where did we say that angle D was congruent to angle N? That's our first angle. Well, that was in step 1. What step did we say DS was congruent to AN?
And 3.
3. And what step did we say angle S is congruent to angle A? 4. That's it. So now we have proven if you just know 2 angles and any side, that if the side's included, they're congruent by angle, side, angle. If the side is not included, they're congruent by angle, angle, side. Okay? So, back to our other page, we now have a fourth one. Today we're adding one more, and it's called angle, angle, side. And it is 2 pairs of angles are congruent and a pair of non-included sides are congruent. Then you know the triangles are congruent. So these 3 work. There's only 2 that don't work. Of all the combinations you can do of letters, the 2 that don't work are, remember I was hesitant to even write it, is angle, side, side, and AAA, angle, angle, angle. Okay, because you could have 2 triangles where all the angles are congruent, but they're very different sizes. Okay, so those 6 combinations cover everything you could have if you know 3 things. Because if you know all 3 sides, that's side, side, side. If you know 2 sides and an angle, either that angle is included and it's side, angle, side, or that angle is not included and it's angle, side, side. If you know 2 angles and a side, either that side is included and it's angle, side, angle, or that side is not included and it's angle, angle, side. And then if you know 3 angles, well, that's that. Okay? Yes? Between the 2. So a side that is included between 2 angles is the only side that both of those angles share. Okay, so like if you're talking about this angle and this angle, the only side they share is that one. So that's the included side. Both of these sides are called non-included. Okay, now if you have 2 sides, that's the included angle, and both of those would be called non-included angles. Okay? So, non-included side is okay. But not, that's angle, angle, side. But non-included angle is not okay. That's angle, side, side. Okay? All right. Let's do a proof. And then I'm going to let you get started on your homework. Okay? So, let's look at this one. Now, this has a new thing in proofs that we haven't seen yet. So, I'm going to show it to you. Okay, this is P, R, S, X, T, U. And you're going to be given that angle PSU is congruent to angle PTR, and that side SU is congruent to side TR, or segment. And I want you to prove that segment SP is congruent to segment TP. My initials or toilet paper? TP. All right. So again, just for clarity, I'm going to write the two given things on two different lines. Okay, so we've got angle PSU is congruent to angle PTR. Angle PSU is congruent to PTR. Okay? Then we were given that segment SU is congruent to segment TR. Now we have a problem there. How would we mark that? It's really hard because that X is in the middle, right? It's hard to draw a segment SU. Now, technically, if you had to, you could do like a little arc that comes out and mark that with a hash, and an arc that comes out here and mark that with a hash. But what I like to do, and your book even does this, usually I've never seen them do this, but do you see that we have two triangles that are overlapping? That have, one of them has a side of SU, and one of them has a side of TR. So what I'm going to do is draw these triangles so they're not overlapping. Okay. What would these three vertices be? What would this one be? S. What is this one?
U.
U. And what is this one?
T. Actually, P.
P. Okay. What about this one?
T.
T. What about this one?
R.
R. What about this one?
P.
P. Okay. So now, on your scrap paper, and I'm actually literally going to get scrap paper this time because I don't have it in. What are our four ways to prove two triangles are congruent? We've got side, 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 angle, side, angle, side, angle, and angle, angle, side. You need to be able to rattle those four things off really fast, okay? So we now know, let's mark anything we've marked over here, let's mark it over here. So we now know that SU as well is congruent to TR, and we already knew that this angle was congruent to this angle. Okay? So do y'all see that I just took this triangle and drew it there, and I took this one and drew it there. Kind of just pulled them apart. So, which one of these do you know we're not going to use now? There's one that we know we're not going to use. What'd you say, Isaiah? Why? Because we know an angle. So if we know an angle, we're already part of the way to one of these, right? Okay. So if we were going to use side, 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 what would we need to be able to prove? I mean, if we're going to use side, angle, side, sorry. I don't know if I said side, 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 or side. If we were going to use side, angle, side with this information, what would we need to prove? TP, right? We would need to show that that's congruent to that. Well, we can't prove that. You know why I know we can't prove that? Because that's what we're trying to prove. So if we knew that from just the given, there would be no proof to do, right? So we can't prove SP is congruent to TP. Since we can't prove that, we can't use side angle side. Okay? What would we need to know to use angle side angle?
You know that angle U is going to be with R.
Right. Can we prove that angle U is congruent to angle R? On this picture, do we have anything that lets us prove that? No. On this picture, do we have anything that lets us prove that angle U is congruent to angle R? No. They're not vertical. They're not alternate interior, parallel lines. There's nothing, right? So we can't use angle side angle. Okay? What would we need to know to use angle angle side? And I hope we can figure it out, because that's our only option. What is the only other angle? P. Could we prove that angle P is congruent to angle P? Why? It's the same thing, reflexive. And it's not as obvious here, but here you can see that it's the same angle. This triangle, that angle, is the same as this triangle, that angle. So you can mark it there, and you can mark it here, and you could say that. Now, can we call it angle P, or do we need to use letters, more letters? No. There's only one angle at P. So we can say angle P is congruent to angle P. Now, what is the reason we know angle P is congruent to angle P? Reflexive property of congruence. Okay? So now we have it. We have angle, angle, side. We have two angles and a non-included side, right? Two angles and a non-included side. So we can say, now we have to be careful. I'm going to call this triangle SUP. Okay, so S on this triangle corresponds to what on this triangle?
T.
T. U on this triangle corresponds to what on this triangle?
R.
R. And P on this triangle is what on this triangle? P. Now remember, just because it's on both doesn't mean it always corresponds to itself, but this time it does. And we can use angle, angle, side. Now, what step did we say the first pair of angles was congruent? Sorry? 1, right? What step did we say the second pair of angles was congruent? 3. What step did we say a non-included side was congruent? 2. Okay? Now, what did I tell you? Every single time you say two triangles are congruent and you're not done, what is the reason? Now, I didn't tell you what the next step is, but I know what the reason is. Every time, CPCTC. And what that means is, once you know these two triangles are congruent, all the parts you haven't proven, you now know they are. So you now know that this angle is congruent to this angle, right? You now know that this side is congruent to this side, and you now know that this side is congruent to this side. Which one do we need? This side is congruent to this side. So we can say, because they're corresponding, segment SP is congruent to segment TP. And you're done. All right? So again, your homework, that was my scrap paper from before, is page 218, 15 through 41 odd, and study for quiz on 4 and 4-5 on Wednesday. So we're going over 4-6 tomorrow, but that will not be included on Wednesday's quiz. All right. Let's see, geometry. What is today? November 6th. Yes. 1 second. Because I'll have to find it because I actually think I haven't put them in the computer yet. But if I don't find it before class is out, I will definitely show you 6th period. And if y'all want to come down here because it'll be quieter, 6th period, this room will be empty. And yeah, I can help you too.